right, the fundamental theorem of calculus. So, to finish this up, to wrap up, chapter 5. There's a step missing from what's shown here. Does anybody know what it is? Because some of you got minus points on your quiz. Okay, what about it? What do you mean plus C?
Oh.
You're right.
Okay.
How do I write that? What's missing? Okay, well, the way we're supposed to write this is that you have a bracket and you have f of x plus the c, and then we go from a to b like that. That's missing, and then we end up with the f of b plus c and the f of a minus plus c, and we distribute. So all that stuff is missing, but you should understand that it's there, okay? All right, suppose that you are given f of a equals c. In other words, suppose you're told what the constant is. You're told the plus c value. Okay, what does that allow you to do with the integral? Okay, well, if we know the plus c value, then we're going to have this be equal to f of b minus c. If we know that f of a is equal to c, if we're given that, then this is what we're going to end up with. How would we make that? I'll just tell you. We want this to be a plus c. So in order to make it a minus c into a plus c, we got to move it to the other side. So it's a plus c. So I'm going to move it over to the other side. A to b, f prime of t dt. The plus c then goes on the other side, and then we have f of b by itself. The beautiful thing about integrals is you can move pieces around to get things alone that you want to get alone. What if I wanted to get the plus c alone by itself? Move the integral. And then what would that look like? That would look like c by itself, f of b minus a to b f prime of t dt. So integrals can be manipulated based on what you want to have alone. Okay, if I want this part alone, I just need to move things around. I just want you to know that is legal. You cannot multiply, you can't divide, but you are allowed to add and subtract the pieces to move them from one side to the other. All right, this having it manipulated in this way is really helpful, especially when we tie it to accumulation, which we did for our quiz. Okay, we did like how many bushels of potato have been accumulated in total over time. In a real life situation, you're always going to be given the plus c. You'll always be given the starting value. All right, so this is what we call in calculus the initial condition. It's like a head start almost. It's how much, so like when you're born, your height is not 0. Okay? None of you were born with a height of 0. You were born with your initial condition of your height being 22 inches or 19 inches or whatever you were when you were born. Okay, that is called your initial condition. The same thing as your weight. Like you're not born with 0 weight. You're born with a starting weight value. And so in these word problems you're going to get, you're going to have an initial condition, something that you start with. A fallacy is for students to think that you always start with 0. They think, oh, well, if time is 0, then I must be starting with 0, which is not true at all. Very rarely do you actually ever start with 0. You actually usually start with something. All right, so in a non-word problem way, here's how you might see something. Find f prime of x if you know its derivative is e to the negative x squared, and f of 7 is 3. The f of 7 being 3 is the initial condition that you're starting with. In a visual sense, it means you've gone out to 7 on the x-axis, and then you go up to 3. So it's like out to 7, up to 3. That's what it means. We're starting with a head start value of 3. Okay, well, how do we find the rest of it? So we define it this way. f of x is equal to the starting value of 3. That's what the c value is. I get to start with that much. After that, from the number 7 where I am on the x-axis, I'm going to keep finding all the area under e to the negative x squared. And I'm going to go an unspecified amount. So my upper bound is what we call x. Think of it like area. 3 is the head start of where you're at. So if you're on a number line or on a graph, here's 0, 1, 2, 3, 4, 5, 6, 7. We're already starting at 3. From that 7 point on, and we just want to keep going in a positive direction for all the other x's that way, we're going to keep getting more area, more area, more area. We're going to accumulate area under this curve. But 7 is the head start. That's just how you create the function under the curve that you're following. Let's try another one in a similar way. Find g of x if g, yeah.
Is that the answer?
Yeah. They just want us to find, to write an f of x. Now, what if they said, find f of 10?
No, then actually do something.
Well, once you have the f of x,
Plug it in.
then you can plug in the number 10. What does it mean? It means you're going and stopping at 10.
Yeah.
And then how much do you get by the time you get up to 10? Okay?
Thank you.
Yeah. Okay, so find g of x if you know that g prime is the square root of sine of x, and the initial condition is negative 1, 7. This is a way of solving problems when you don't know the antiderivative. There is no possible antiderivative for something that has a square root and a trig function at the same time. Okay, we cannot do an antiderivative of that. So we write an equation. So we say, okay, then g of x must start with what value? 7. Okay, it starts with 7. And then from negative 1 to any other number, I can follow the curve of the square root of the sine of x dx. And that's how I'll find any other value after that. From there, I can go any direction I want. I can go forwards from negative 1. I can go backwards from negative 1. But the initial condition is negative 1, 7. So again, thinking about it on a graph, negative 1, 1, 2, 3, 4, 5, 6, 7. We're starting right here. And from that point, we are either, if the number is bigger than negative 1, then we'll be accumulating area going up to the right. And if the number is less than negative 1, we'll be accumulating area going backwards. And we'll let our, but we set it up this way, okay, because there is no antiderivative. Okay, so Tyler, here's your question. I added find the function, and then I put then find f of 7. Okay, so first find f of x. Do you want to try it, Tyler?
Yeah, I think it's
What's our initial condition we're starting with?
57.
Okay, 57. All right, plus,
Plus the integral from 3 to x
uh-huh,
as tangent x
yeah,
dx.
very good. And along the x-axis, okay? Okay, it's getting a head start. Okay, then we can find f of 7. So f of 7 would be still starting with 57 and going from 3 and stopping at 7 of tangent of x dx. Then you would solve 3 to 7 either with geometry if you know it, antiderivative if you know it, or Math 9 if you get to use your calculator. Okay? The geometry on tangent doesn't work out nicely. The antiderivative of tangent doesn't work out nicely. So this would be then a Math 9, and you'd grab it and you'd figure out. You just don't forget the 57 at the beginning. 57 plus the Math 9. Okay, guess what method we're going to use for this one? Geometry. Okay, now this is an interesting one. Read carefully. What is the function that's graphed Really?
Graph of x.
What's the function that's graphed?
Oh, graph of x.
Oh, interesting. It says graph of f. Okay, as not a g, that is an f. Okay, but all the questions are about g. So we have to trust what's given to us about g, which is right here. All right, so find g of negative 1. All right, well, we're given the equation for g, so g of negative 1 would be, g of negative 1 is going to be the integral from 0 to negative 1 of f of t dt. So the meaning of that is to find g of negative 1, you're going to look at the graph of f, and you're going to measure the geometry from where to where? From 0 to negative 1. What direction is that going?
Backwards.
Backwards.
Negative.
As you look at the area from 0 to negative 1, what shape do you see?
Triangle.
A triangle. But to Tyler's point, we're going backwards. And so the answer for that should be a negative number. So it is going to be negative 1/2 base times height. And the base is 1 and the height is 3. So the answer is negative 3/2. All right, now we're going to find g prime of negative 1. Before we can find g prime of negative 1, we need to know what g prime of x is. How are we going to find g prime of x? Okay, do we have regular g of x? Yes, so how are we going to go from g of x to g prime? Take the derivative. So we are going to take g of x and apply a derivative to it. And on the other side, we're going to take 0 to x f of t dt, and we're going to apply a derivative to it. That will get me g prime of x. So g prime of x, we just learned how to take the derivative of something that has the integral. The derivative of something that has an integral crosses out the integral, crosses out the dt, but I have to plug in the x and the 0. So I'm going to get f of x times the chain rule of 1 minus f of 0 times the chain rule of 0. So ultimately, the 1 and the 0 get me this. So g prime of x is f regular of x. And now I'm asked to find g prime of 1, negative 1. So g prime of negative 1 is f regular of negative 1. And f is the graph, so what is the regular f of negative 1? Yeah, it's just sitting right here, right here. Okay, so the answer to that is 0. Finally, I'm supposed to find g prime of negative 1. Before I can find g prime of negative 1, I need to know what g prime of x, g double prime of negative 1. I need to know what g double prime of x is. If this is, right here, g single prime of x, which turned out to be f regular x, what would g double prime of x turn out to be? F prime of x. So g double prime of negative 1 is equal to f single prime of negative 1. And how am I going to get f single prime of negative 1 off of the graph? It's the slope. Single prime is the slope. And can you count the rise over run on that? Up how many over how many? Up how many over how many? Up 3 over 1, up 3 over 1. So the answer is 3. So I answered all the questions about g using the picture of the graph of f. Okay, we want to try that again. I want to ask you questions about g, but only give you the questions about f. All right, the question is, for what values between negative 2 and 2 would g be increasing? So we have to trust our definitions here. That's why I've been pushing you so hard on your definitions. G, let me say g of x. I like that better. G of x will increase when Okay, just in general, don't give me like specific numbers or anything, but when do you know that something increases? It is above the graph. We're not, okay, so we're going to try. I like what you're thinking, but I want to try and get rid of, okay, when G will increase when the slope will increase. You're on the right track, Carla. Okay, when the derivative is what? Is positive. G will increase when the derivative is positive. Okay, G of x will increase when the derivative is positive. What did we say on the previous slide was the derivative of G of x? Okay, look back. What did we say was the derivative? Oh, yeah, f of x, right? Sorry. In other words, so AKA, G of x will increase when f of x is positive. All right, well that means we get to get our answer from the f of x graph. When is f of x positive, which simply just means it's above the x-axis? From -1 to 1. Okay, these are not easy because they take you thinking about a definition before you jump to try and answer the question. Okay, let's try something about concavity. For what values from -2 to 2 will G be concave up? All right, well, define G being concave up. G of x will be concave up when what is true? When G double prime is positive. That's the definition of concave up. What did we associate G double prime with? F prime. So AKA, in other words, also known as, G of x will be concave up when F prime of x is positive. So how are we going to get F prime of x to be positive off of the graph of F of x that we're looking at? Okay, so when is F prime positive? Okay, from where to where? Right, this whole section right here has positive slope. So on -2 to 0. Good. Define it first, then try and answer the question. Okay, let's try another one. Find all intervals on which G of x, so different graph now. Find all intervals on which G of x is less than 0 from -4 to 12, this whole picture, and justify your answer. Okay. All right, well, how is G of x defined? So let's look at this. What does that mean? What meaning does that have to you? G of x is defined starting where? At the number 2, okay, and what are we doing after from that point of the number 2 on? So we're defining G of x starting right here, okay, and then how are we defining G of x? What does this mean? The area under or between f of x and the t-axis line. Okay, do we know what direction we're going from the number 2 yet? No, we could be going forward and we could be going backwards, but we're starting at the number 2. Okay. So when would that turn out to be negative? When the area is negative, or not just when the area is negative, or when you're going backwards. Okay, so starting from that point, how do we get negative area? Okay, give me from here to here. I would for sure have negative area. Okay, I heard from 2 backwards to -2. If I go backwards, I'll for sure have negative area. Okay, great. When else would I have negative area? 6 to 10. Remember, where are you starting from? You're starting from 2. So even if I go 6 to 10, I will have started at 2. So this is all going to be positive. And then say I cross over. Am I positive or negative? I still am positive. I don't have enough negative to cancel it yet. So, okay.
10 to 12.
Yeah, so I'm still, the net total is still positive until I get to here. Because once I get that far, the positive and negative canceled out. And after that,
Net negative.
now it's net negative. So I have 2 answers from -2 to 2 and 10 to 12.